How do you guys feel about those?
Yes.
It's not as scary as you thought it was? All right, so I want to show you the other special triangle. So this, is a regular triangle. A regular triangle. What makes a regular triangle special, Evan?
45 degree, 90 degree, 45 degree angles, 60 degree angles. Hold on.
They're all the same.
Thank you. Yeah. All the sides are the same. In this case, though, we're going to label them all 2. And all my angles would be the same, aka 60s. Okay? You all right with that? And what we're going to do with this guy is we are also going to cut it in half, like so. And then we're going to ignore this piece of it. That changes some values, doesn't it? Is this still 2? No, if you cut it in half, now it's 1. And if we use a perpendicular bisector to cut in half, then this angle is now 90. That was 60. Now it's 30. So now it's a matter of using our Pythag again to get this other side. And I'll just tell you that it's going to be radical 3. It's going to be radical 3. Anybody need to see the proof? No? No takers? I love that sweater. It makes me happy. The color does. Because I don't really know San Diego. Color is awesome.
Wait, Mr. Mia?
So,
Isn't like A squared plus B squared equals, right? C squared? Yeah. Correct. What about it? So that would be 4 plus 1.
4 plus 1.
Because the hypotenuse is the C, so
Yeah, this is the hypotenuse. That's the.
1 squared plus
It'd
B
be 1 plus I don't know. 1 squared plus I don't know squared equals 2 squared.
I do get that. I understand that.
Did you register?
Right?
Yes. Wait, what did you do?
I used a question mark.
I wrote down for 2 seconds.
We ended up doing the math to get radical 3.
Oh, that's a question mark, but it's 2. That makes sense.
You guys good? Okay, so I'm not even going to teach you the other part. You're going to do it yourselves. I'm going to copy all this and erase this. So we will start at 0, but then we're going to go to 30. Then we're going to go to 60. That would put us at 90. Then we're going to do another 30, which would put us at. So all I'm going to do really, rotate here every 30 degrees. Okay? And watch how you already know how to do this. Go ahead and fill it in with radians. I'll remind you that this is pi. Go ahead and fill in the radian measures. Yeah. I'll do your degrees. I just had a brain fart. Did you see me staring at this? You did. Finish it. Good job. Good job. Look at you. I told you you knew how. I didn't have to tell you nothing. Look at Good job. Good job. Are you just starting your schedule? What did I do the first time? What did we do the first time?
I don't understand how you made the
So how did you reproduce it to this?
circle?
So know the first part, but I don't know the radian.
It's just adding 45s and adding a quarter pi.
Why a quarter pi?
It's a quarter of a circle.
How many pieces does this one have?
This one is 10.
13. 12.
Yeah, but just pi. Just the top pi. Because remember, I didn't, for the 45, it was like pieces. But you did quarters. This is eighths, right? You did quarters every time, right? How many pieces were at the top?
5.
You're missing a thing.
8.
There was 4 pieces.
4. Wait, do you not count this?
So now how many pieces is this in on top?
4. That's 4.
No, you count them, bro. They're 6.
It's supposed to be counting the spaces. I still don't see how that helps me. That's great.
I don't know. You just created it. I didn't teach you jack shit.
Why do you sound like my dad yelling at me doing that?
No, I didn't know you did it like that.
That's it? I figured it out, guys.
I thought this was what I wanted, but now my lips are going to be chapped. It's like, you're like making me doubt myself. Maybe.
Find a one. Perfect. No more, no less.
I know they're both.
What's 30 degrees? What's my radian measure? Pi sixths? 2 pi sixths? Right? This is 3/6 pi, 4/6 pi, 5/6 pi. That's ugly 5. 6/6 pi, 7/6 of pi, 8/6 of pi. Yeah, I just had a brain fart. I'm sorry. 10/6, 11/6, and then 12/6, right? And of course you can simplify them. Guys, that's where the radians come from. There's your whole unit circle. You put this one on top of your 45/45. That's your unit circle. You guys are good? Well, we're going to get to that. Not right now, though. But remember how I did these guys? All we're going to do is add those values once we get to that, okay? So don't rush to put in the roots and all that. If you have this for now, I'm satisfied. Give me a thumbs up if you're good. You can produce this again. Awesome. Fantastic. Unit circle not so scary? Riley? Okay. Because Riley looked at me and he looked away really slowly. All right, cool. Cool beans. We did revolutions. We did that. We did that. We did that. You guys can draw in a standard form, right? Like if I ask you to graph negative pi fourths, you're going to go negative direction, correct? Then you'll go to what, 45 degrees here? Or negative 45 degrees, if you will. We can do that? Okay. I don't think that's a lot of 7 pi fourths is going to end up, or that negative 7 pi fourths will end up up top. Okay. We just did this. Good job, yo. Yeah. It's not so crazy no more, right? All right, cool. Moving on. Positive angles in terms of revolutions. Kind of should make sense to you, right? If you want to write this down, you can snap a picture if you want to have this chart. If you do a full revolution, how far did you travel?
360 degrees.
In radians?
2 pi.
2 pi. And then if you're doing any portion of that, all you're really doing is multiplying that portion revolution by 2 pi. It's kind of like taking, remember that percentage formula? Sorry. That's what you're doing. Right? How do you find 10% of 50? You multiply them. That's what we're doing. See that? So don't let that scare you.
Wait, are you recording?
No, I'm recording.
That's good.
Cool? We're good? Yeah, that's a lot to write down right now. Is that more the same, or did I just rewrite that? That's the same thing? Oh, that's the other part of it, isn't it? Yeah, just another part of it. You guys want a picture of that? Hiya. Hiya. Hey, Evan, if I'm pointing at you and I want to rotate, how many degrees would I have to rotate to be pointing at you again? 360 degrees, right? So, if this is, we'll say it took me, what's that? We'll call that 0. That's about what, 100? 120? How many degrees would I have to rotate? What would be the next angle that's coterminal to you? What is the next angle that's coterminal? If the first one was 130, then the next one would be, what did I say?
120.
And what did I say?
0 to 120.
120? Oh, my bad. Okay. So 120, what's the next angle that's coterminal to you? 40?
Let's go to 80.
Oh, 480. How'd you do that?
Why am I doing that wrong?
You got 360, right?
Oh, so I did it.
Yeah, because I'm just rotating 360. So what would be the next one after that?
480.
Did you do it twice already?
8.
He's trying. No.
They stopped looking.
And you know what? I can't do it like you're doing it. I put it in my calculator. What I would do, was it 840? I would just go plus 360 if I want another one. Plus 360 if I want another one. Plus 360. Okay. Now, that's the way I can get positive ones, right? But what if I wanted negative angles? Instead of adding, I would subtract until that number becomes 0? Well, it is going to be coterminal, right? So we're at 120. Is that what I said?
Yeah.
I want to get a negative number, so I'm going to rotate the other way, right?
Yeah.
What would that be as a negative number?
Negative 360.
Negative 240.
Negative 2.
How much?
Negative 240.
How'd you do that?
Subtract 360.
120 minus 360 would put me at negative 240. So if I want positives, I would add 360s until I get a positive number, or more positives. If I want negatives, I'm going to subtract until my angle becomes negative, and I would continue to subtract if I want more negatives. Does that make sense? For you rule people, theta plus or minus 360k, where k is an integer. It's just the number of revs, or how many angles you're looking for to be positive or to be negative. If you do this in radians, instead of 360, you would do 2 pi. Absolutely. And that's right over half. Anyone have questions on that?
Yeah. What? Start from the top. I'm confused. Like, can you draw it? Because that visual is not helpful at all.
Okay. Oh no, this yeah.
No, like the little.
Oh, my little visual. Okay, so let's say I had an angle, and I think we said was about 120. So let's say this is 120 degrees, right? I want another angle that stops right here as well. In order to get it, I would have to add a full rotation, right? I have to go all the way around to stop there again. So what did I have to travel? 360. So I would go, well, 120 plus 360 is 480 degrees. So the next one that's coterminal is 480 degrees. And if I want another one, if I want another angle, then I'm just going to rotate one more time, right?
Yeah.
And then I will have to add another 360 to that.
Yeah, I get that.
That's all it is. Now if I want the negative ones, instead of going, here's my 120.
Yeah, you go backwards.
So I
That's
would
what you were
do,
saying?
yep, I would go this way. But instead of adding the 120, I would have to, sorry, instead of adding the 360, I would have to subtract the 360, wouldn't I?
Wait,
So,
subtract 360.
huh? Because these directions are negative numbers, right?
Yeah.
Right. So that would produce a negative angle for me. Because remember, this is positive 120, right? So if I get to here, where am I at? I'm at 0. But I'm not done with my rotation, am I?
Oh.
So I would need another negative 90, a negative 180, and then I'd be at negative whatever the difference is.
Okay, that makes sense.
Yeah? Good. And if I want radians instead of 360, I would use 2 pi. Cool beans? Thanks for asking. Anybody else? Here's what it says. If I'm working with, if I don't want degrees, I want radians. Instead of using 360, I would use 2 pi. Because 2 pi is a full revolution. Cool beans. What?
So what's that?
Let me see what my intent was, okay?
A 400 degrees. Sure does.
Oh. Give me the smallest possible coterminal from 400. Give me the smallest possible coterminal
Like negatives included.
angle. What? Hold on. Keep it yourself for now. Find me the smallest. That H threw me off big time. What is the smallest coterminal positive possible here?
Positive.
Positive. I could do my pluses and minuses.
It's not the smallest. You're adding it.
I think mine was like
Yeah. on the 360 and your license?
Alright, question goes to.
What did you promise?
40. But I'm no longer wrong.
I didn't do attendance.
I figured it out.
Come on, you already have the answer. Jade, what is it? Can you tell everyone how you did that?
Subtracted 360.
Yeah, if my angle is 400 degrees, I can take away 360 from that. I'm going to get 40 degrees, right? Do I want to keep subtracting?
No.
Because then the next one would be a simple enough? Mind blowing? Okay. Give me. What am I doing?
The same thing.
What does A mean?
Okay, how about this? Do the coterminal.
I don't know.
Yeah.
Two questions here. Give me the smallest positive and give me the smallest negative possible here.
Yeah, I actually have to do that.
Just smallest negative. I could just go forever.
Smallest negative. Wait, really?
Oh, sorry. You're right. Oh, you caught. That was good. That was quick too. Cause we could go. I guess what I want to say. The negative closest to zero.
The biggest
Or-
negative.
Yeah, that's kind of weird. It still blows my mind.
Biggest
So the
negative.
biggest positive, negative, and the smallest possible positive. That sounds weird.
We know. We know. So.
The biggest positive, negative, and then
The biggest negative possible, and the smallest positive possible.
okay.
Yes.
Closest to 0.
No.
I think you and me.
That's what she said.
That's what she said.
No, because remember, the more negative, the smaller you are.
Just say anything else.
Right? That's what you're saying, Maddie, right? Because negative numbers get smaller as they go off toward infinity. Yeah.
Okay, but that's
It's just what you say. It's not a big deal.
okay.
Can I get a calculator?
I know. I got. Thanks for that one today, Maddie.
Yeah, no, I was already technically. You and me are thinking the same thing.
You broke skulls.
I was okay with it. I would have
It's in my mind too. It sounds weird, doesn't it? But it's not. It's correct.
Yeah. It's actually put the negative number close to zero. The closest number. Wait, do we have to do a no?
225 for that.
Negative 135. Oh wait.
I'm gonna be thinking about that all day.
No, is that not how that works?
Can we just use that?
Yeah.
Can we just use that as the answer?
Are we able to use that?
Yeah, why not? What's wrong with it?
That's how I
It's
was
a perfectly good number.
So I have that.
Yeah, that's what well, I mean, I saw it in 325.
Actually,
What are your answers?
Yeah.
why aren't you driving?
Do you guys get 135?
Explain this to you.
Why don't you try it?
My parents said no.
Just go to the DMV and pay yourself.
How the fuck am I supposed to do it?
And you need a car too. You're gonna walk to the DMV, you're gonna walk to the driver's test.
From the same spot.
All right, what's my smallest positive?
225.
And the largest negative?
Negative 135. Right?
No more times 5.
Negative
That would be it.
495.
Remember when
There's
Omar,
nothing to do with it.
Oscar waved at me?
Yeah!
Oscar waved at me?
Negative 135 will put us at
Yeah. the coterminal itself.
like right here, right?
Yeah.
But yours would have more rotation still. So it would be smaller still.
Maybe you're finding a coterminal on the same
No, it's the smallest possible that's coterminal with that. Well, it is itself.
coterminal means another
But the way you
one.
interpret it, you're correct. Yes, you're correct.
But it's still coterminal, it's the same.
Yeah, she's correct. The way she interpreted the words, you're correct.
Guys, when you
Not the intent of what I wanted, but you're correct.
We didn't even do it. Okay.
She's correct. I want to point that out too. Coterminal, I'm just repeating what Maddie said because technically she's correct. I was really just hoping to get 135 back. Thank you. But the wording was wrong the way I said it. I said find a coterminal angle, right? So technically, what was the number?
495.
Negative 495 should be the next largest negative. that is coterminal, right? So I just want to point that out. So if you did 135, okay, that's what I was thinking too, but we are not correct because that's not coterminal. That is the angle.
Oh,
That is the angle.
So coterminal cannot be.
Has to be another one.
Oh,
Okay.
okay.
So, all right. You were right. Now you were right with my wrong answer. All right, cool. Let's move on. We're okay with those though?
Yes.
All right, let's move on. Believe me, that is going to be an important skill to have. It's going to be an important skill to have. Get this formula down.
He just walks out of class. I'll see y'all later.
That reminded me of you watch Key and Peele?
Oh yes.
And the substitute, the part 2, I think, he comes in like real hard.
Or he pronounces their names wrong.
No. You guys see that when he comes in, he's got his briefcase, he's like all business, and then everyone gets all quiet because he's like all business, and then he puts down his briefcase and he toots, and then he starts talking, he just picks up his briefcase and walks out the door. And he's like, I just lost everybody.
Like the one where he's like,
Mr. Munoz, I thought you were chasing your beard.
Probably this weekend. I don't know. I'm conflicted.
Shave it.
Don't do it.
Shave
Throw it out.
Keep it. Shave it.
Well, we were messing around with the Snap last night. We like looking at the filters.
I want you to look
And
like
there's a
that.
Viking one. And I told my wife I was going to grow it out and put the little Viking locks on here.
Just get like a little curl.
Oh, I used to do that.
That one, like
I have pictures of
guy
that.
from Balago. Like the one with the this mustache. You know the one.
Okay. S, arc. Arc. To find arc length, you're just going to multiply the radius by the measurement of this angle. So if you want to know how long this is, you're multiplying the radius by the angle measure. Whether that's in, and you're going to want that to be in radians because that's what your converter is, right? So if you have degrees there, you want to convert it to a radian measure and then just multiply it by the radius. Okay.
I say shave.
I say don't shave.
I say we have a vote.
How about I decide?
No, let's take a poll.
Who do you think you
Yeah,
are?
let's take a poll.
All right, everyone have their formula down. No, I'll wait for you. Go ahead.
It's radius times.
It's the radius times the measurement of this angle.
Measurement of angle.
In radians, though. But that should make sense, right? You guys remember the other formula we did when we were talking about radian measures? It's pretty much the same thing, isn't it? You want to know how many radians there are? No?
How many radians there are?
Did you give him a peanut?
No, it's a rubber band.
Oh. I thought it was like trail mix, and you're like, here's a peanut.
That's me.
All right. You have it now, bud? Yes.
Oh yeah, I got that.
We're waiting for you. All right, here we go. Finding the length of a circular arc. A circle has a radius of 6 inches. Find the length of the arc intercepted by the central angle of 45 degrees. So you've got 45 degrees in here, yeah? You're trying to find the length of this bad boy right here. What's this distance? Okay? And you can just use your formula for that.
Oh, in terms of.
You need me to write the formula again?
Oh, just kidding. I don't understand. It's just 6 times.
You don't understand?
5.
Do you understand what we're after?
Yeah.
We want this distance. And I gave you a formula for that. The formula, I believe it was S, right? You're going to multiply that angle, the angle, in radians though, by the radius. What's the radius of this bad boy?
1/2 pi.
The radius is 1/2 pi?
It's the first
All you're doing is plugging everything in.
Oh, the radius is 6. I thought you were 3.
So 6 times,
45.
not 45. It's got to be in radians.
6
If you want them, if you want the measurement, you want to be in radians.
6 times.
What is it?
We arrived.
So multiply those two.
Oh, and then you round it. Oh, okay.
You just leave it like that.
Yeah. It's in the back. I have to cover it.
What?
wasn't r theta?
It's on it.
Doesn't matter.
I'm trying to be silly.
But I don't know if it was your one me.
Waterfalls. So, I want to find that blue distance. The radius happens to be how much? 6. And what's the measurement of that angle in radians? It should be pi fourths, right? If I could draw pi. Pi fourths. So this is going to end up being 6 pi fourths. 6 times 3.14 over 4. What is that, like 18? How much is 6 times 3.14?
Oh, we're supposed to.
Yeah, you actually want a number.
I just know like 13.6.
That can be 13.
Oh, we didn't do pi.
Oh, is that what you got total?
No, I'm just kidding. Top was like 18.
18.84. And then this was 4, right? So what is that?
4.7.
Okay, that'll work. Questions on that? Simple enough?
And that makes it like the inclusion egg.
Okay, what's the 2 decimal points then? Alright, 7-1 then. Thank you. Okay, grab these formulas. You want the linear speed formula? That's V equals S over T.
Oh, yeah, no, that's always, yeah.
I just wondered who Sarah is though. In like the first quarter, Evan would always try to get the lily seat, the one with hair on it. There's always hair on the seat in here. Ah, whose hair falls out that much? Probably mine. No, it was curly. I could have swore it was curly.
Lift it up so I can.
Me too.
No, no, it's just falling on the back of the chair. Yeah.
Touch it.
MJ, you got these formulas down?
I just want to take a picture.
You go back and look at those?
No.
I just wondered because.
I'm not gonna look back at my notebook either, so might as well take the easier route.
But why are you taking pictures if you don't look back at them?
Might as well have it.
Because I have it for the cloud storage.
I do not.
Those are ridiculous.
I probably have like 300 tops. 300 tops? Yeah.
Disturbing my energy, bro.
Probably more, actually. I don't know.
You say
I
disturbing my energy?
580.
I have 9,000.
Listening to my chakras?
How do you have so many pictures? My phone's like, you can only have like, I don't know, 12 pictures, 12 videos, 2 screenshots.
Jade, half, like, literally half of my camera.
That wasn't cell phones growing up in the 2000s.
Like, every day.
You had like
And they're all black.
50 pictures total you could probably take. And then you were like, you're out of memory.
All of them.
Mine could be on pictures. It's not our fault that you didn't want to tell.
I don't have a cut up
My
yet.
impression of Coach Lee kissing.
It was tomorrow, so it's not.
Anybody still writing? Got one more formula for you. This is for linear speed.
What the heck is that?
Linear speed.
What is that? Photo roulette. I thought we were using
Uh,
it's a black screen or it's a picture.
It's not W, it's a Greek letter. Give me a second.
Wait, Miss Maria's picked up.
So-
To the left. Yeah.
That angular, I believe.
Linear.
Linear speed is this. Let's see. Then it's, if a point is in motion on a circle, then this is going to be the linear speed. The linear speed of a point distance from the center of rotation. From the center of rotation.
What is all this?
So let's see here. So this is if a point is traveling around
Wait, what was the formula?
this one.
No, the
So-
second one.
This one or the bottom one?
The other one.
V equals R W.
RW.
See, look,
Okay, go.
it says that every
Okay.
single time, yet it's still taking.
So this is V equals S over T,
The only ones that like say.
where S is the length, arc length, which is this formula. The angular speed is going to be theta over T. The linear speed of V of a point to distance R from the center of rotation. Munoz. No, she's gonna be contact IT and then have them. Yeah, they probably could. Do me a favor. When does she have prep?
There's like the other one if I need it.
Okay. She needs to start making CD charts. Would you let her know to do that?
Jason knows too many. We're at safe play.
Okay.
I don't text on Snapchat.
You know, obviously you don't text them.
If you call Phil, you can do an install and put the license in there and everything. Or she can come see me and try to well, whatever. Either one works.
This is my dumbass friend. Saying she's gonna beat the pussy out of my other friend.
Okay, well then just do it during 2.5. Do the install on that, okay?
That's funny.
Alright. Alright. Talk to you later. Bye.